Justin Murray from Technical Marketing at VMware in Palo Alto, California, and I wanted to talk to you for a few minutes about virtualizing big data on vSphere. The first thing I would look at would be the type of users that we have here. And in the big data and data science community, we have two main types. We have developer testing and we have production. And there isn't a clear line between the two. But when we look at the communities, they have different concerns. Developers and testers are concerned with experimenting, doing data science experiments, different models, different algorithms. Their world is very flexible. They're spinning up and bringing down clusters all the time. They're really in single tenant, single purpose mode at any one point in time. Whereas production users, there's a single version of the software. There aren't multiple versions in use at once. They're really multi-tenant in having different communities of use. And they're concerned with SLAs and stability. And both of these types of users are easily doable on VMware. They can be implemented on VMware. I'm going to look at the architecture now of a typical big data cluster. And here we have the client submitting jobs into the master, or in the case of Spark, which is contemporary Hadoop technology, submitting it to the driver. And in some cases, the driver may be over here, but in this case, I'll put it over here. And then finally, that master or driver is submitting individual pieces of the overall job to the various executors, which I've indicated with ease here. These are just Java processes running on worker physical machines in this case, and I'm going to map them into virtual machines. And each of these workers has some direct attached storage. That could be spinning disk, or it could be flash. It could be any type of storage, typically local, but other forms are available now as well. And when that architecture has virtualization applied to it, it's really quite simple. We map one or more executors into a virtual machine like this, and we can do that throughout the cluster until we've effectively segmented up our hardware into virtual machines now, each of which contains one or more executors, but they operate in the same way. And of course, we can virtualize this piece as well, which is the master process. We might want to do special arrangements to do with high availability for that, and we can virtualize the client as well. And when we virtualize these things, they use the storage in exactly the same way as they would if they were running on physical. And you get distinct benefits from doing it this way. As you see here, these virtual machines can be mapped carefully into NUMA nodes within the memory space here. And if you do that carefully on VMware, you get the best performance out of it. You actually get even slightly better performance than you would if you did it physically, because we're respecting the NUMA boundaries here, where NUMA stands for non-uniform memory architecture, where each chunk of memory is allocated to a particular processor. So the overall benefits we get from all this are, first of all, flexibility in management. We get the ability to spin these things up as we want to for the developer, and we get to keep them alive as long as we want to. My virtual machines in my lab have been living for weeks, whereas I've spun up and brought down this Spark cluster many times. We get rapid provisioning in that way of the cluster. We get servers that are not dedicated to one cluster. They can be used across multiple clusters with multiple different users on them. And some of our production clusters indeed have more than one Hadoop cluster on the same collection of hardware here. And so what you see here is sharing, as opposed to dedicating this particular collection of servers to one use and one cluster. You're no longer dedicating your hardware entirely to one use. And as I mentioned previously, if you obey these best practices to do with NUMA and other best practices, you'll get performance equal to native, and in some cases better than native. But from the point of view of the original users we talked about over here, the developers, testers, they want to operate in their own sandbox, bring up their own cluster, and isolate themselves from everybody else. And indeed, we want to isolate production from everybody else. That's very doable by virtue of these virtual machines, segmenting them up into resource pools and doing it that way. And as you know, VMware vSphere has been a trusted platform for many applications in the past. It's now a trusted platform for running big data on as well. Now, one refinement of all this is we might insert some new technology in here, which is our virtual SAN technology. And that provides a layer between the hardware and the storage effectively, and allows us to implement shared storage. Even though each of these are local direct attached storage devices here, we now have shared storage. And so with shared storage, of course, we can have high availability. So if one of these workers were to fail, we can reproduce the virtual machines on that server on another available host in the cluster. So that's been particularly useful to me in my work where I may have an unreliable server and I can bring up my executors and my virtual machines in response to that. So these are the overall benefits you get from virtualizing. Thank you very much for your time today. And if you'd like to learn more about this subject, go to www.vmware.com/big-data. Thank you.